Hi everyone, and welcome to Science Kitchen. Today we're going to be describing the materials and methods needed to make a pie from Malus domestica seed-bearing structures. It's a traditional treat, so let's get into the lab and make one. You're going to want 1.8 kilograms of the seed-bearing structures from a Malus domestica. Hi, this is Steve from the future. You are definitely going to want a deep dish pie shell for this many apples, for reasons that will become clear later. If you have a normal pie shell, you should use only 1.3 kilograms of apples. There are 7,500 cultivars, so pick your favorite. I'm using the Royal Gala cultivar. We just want the hypanthium, so remove the skin, endocarp, seeds, calyx, and pedicel. Cut the rest into longitudinal segments with a maximum thickness of 6.35 millimeters, and put them in a glass container. Next, add 134 grams of 400 micron sucrose crystals, and 30 milliliters of liquid from the seed-bearing structures of the evergreen citrus lemon. This will denature polyphenol oxidase enzymes and prevent them from catalyzing O-quinone production that will turn the hypanthium segments brown. If you want to follow my methods precisely, you should now get really busy with other things and store the segments for 51 hours, or just over 2 days. The mixture seems no worse for wear, so either the acids are really effective, or O-quinone production is not a problem in this cultivar. Next, we'll get 60 milliliters of a semi-solid concentrated lipid emulsion. Many people use concentrated lipids from Bos taurus, but feel free to experiment with other lipids, including those derived from photosynthetic eukaryotes. I'll be using photosynthetic eukaryote lipids from Brassica and Elais. Take your emulsion and heat it up in a large non-reactive container until it becomes a liquid. Why did we need to start with an emulsion if we're going to just immediately make a liquid? No reason. That's just what we had in the supply cabinet. Add the hypanthium segments and any liquids into your non-reactive container. Heat at 200 degrees Celsius for 13.5 minutes. Stir the mixture every 2 minutes to ensure even heating. At the end of 13.5 minutes, add 30 milliliters of pulverized seeds. Triticum aestivum is a popular choice, but choose others if you prefer to avoid glutenins and gliadins. Also add 2.6 grams of a fine powder made from the inner layer of Cinnamomum cassia bark, and 6 grams of 300 micron sodium chloride crystals. Stir the entire mixture thoroughly to evenly distribute these new chemicals. Remove from heat and allow the contents to cool to 24 to 26 degrees Celsius. Now preheat your laboratory oven to 190 degrees Celsius. We're going to use a pre-made pie shell because they contain some chemicals that many laboratories do not even stock, like sunflower lecithin. I'm using a 22.9 centimeter pie shell from the Tenderflake Corporation, purchased frozen and thawed in my lab refrigerator at 2.7 degrees for 24 hours. Put your M. domestica mixture in the pie shell, and a second pie shell on top. Pinch the edges together to seal them. You can also pinch them into a wavy shape, which has no functional effect. Hi, Steve in the future again. Absolutely take your time sealing these two pie shells together thoroughly. That wavy shape that you see on traditional pies is in fact a really good way to seal the top and bottom together. This is not sealed, as we will soon find out. Cut 5 slots to allow steam to escape, but also make the pie look like Clypa asteroidea. Optional. Take about 60 grams of mixed albumin and yolk from an egg of a Gallus domesticus, or the egg from any reptile, avian, or monotreme. Brush a layer of egg on the top. I chose not to do this step. Put your pie in the laboratory oven for 65 minutes. At the 15-minute mark, you can use aluminum foil to protect your cosmetic wavy shape from excessive Maillard reactions. And Steve in the future, this is why you need a deep dish pie shell to contain all the filling as it bubbles and boils. This is also why you need to seal the sides well, so that the filling doesn't come bubbling out the sides. I'm reporting my methods accurately so that you can improve this experiment and not make the same mistakes I did. Wait for at least 2 hours before attempting to eat it. When complete, your traditional M. domestica pie may look like this. Enjoy! Steve in the future, this pie was delicious. If you want the original non-scientific version of this recipe, the link is in the description. Thanks for joining in Science Kitchen today. What's your secret to a delicious M. domestica pie? You can learn more by watching another video on this channel, or subscribe to keep having fun with science. Thanks for stopping by this week to learn what makes life awesome.